Welcome back. My name is Dan Dorfmueller. I'm the author of Print Reading for Construction. You may wonder why we dedicate a whole unit to construction math, especially when everything being discussed should have been learned long before the student picked up this book. Well, math is one of the fundamental pillars of construction. Many tasks related to constructing a building require math calculations, from estimating, locating where the property is to be excavated for the foundation, locating where the structural footings may go. So being able to add, subtract, divide, multiply, and convert numeric values is essential to the success of a construction project. In Unit 2, the math application is an overview of this material to refresh your memory and apply math to construction. In this unit, you will learn to convert between improper fractions and mixed numbers, add, subtract, multiply, and divide decimal fractions, calculate dimensions, calculate areas and volumes of objects, and relate math to construction problems. Take a few minutes and review the terms and their meaning in the glossary section of the book starting on page 382. Fractions are written with one number over the other. The number on the top is called the numerator, and the number on the bottom is called the denominator, as seen in this 7/16 and 9/16 example. The 7 and the 9 are numerators, and the 16 is the denominator. Note, when you add them together, you get 16/16, which equals 1. The 7/16 and 9/16 fractions in this example are called proper fractions. An improper fraction is a fraction in which the numerator is greater than the denominator, such as 5/4 or 19/16. In order to reduce an improper fraction to a mixed number, divide the numerator by the denominator. As seen here, 5/4 can be reduced to 1 1/4, and 19/16 can be reduced to 1 3/16. These are called mixed numbers. Whole numbers can be converted to a fraction by adding 1 to the denominator of the whole number and multiplying both the numerator and the denominator both by the same number as seen here in 4/4, now making the 6 24/4. Now let's convert a mixed number to an improper fraction. First change the 3 to 3/1 and then multiply the numerator and the denominator both by 8. Then add the 5/8, adding up to 29/8. Adding fractions. First determine the least common denominator into which the denominators can be divided. Then change the fractions to have the same denominator by multiplying the numerator and the denominator by the same number. In this example, 32 is the least common denominator. To convert 16 to 30 seconds, multiply the numerator and the denominator by 2. Next, convert eighths to 30 seconds by multiplying by 4, and this gives you 10 30-seconds and 12 30-seconds. Now add the numerators and we get 33 30-seconds. Next, reduce it to its lowest terms. We get 1 1 30-second. Subtracting fractions is done the same way, by creating the least common denominator, then perform the subtraction, finally reducing to the lowest terms. Pause the video here and do the adding and subtracting practice problems on pages 20 and 21. When complete, continue the video to see the answers. Repause the video to check your answers. Multiplying fractions Change the mixed numbers to improper fractions. Multiply all the numerators, then multiply all the denominators, then reduce fraction to its lowest terms. In this example, first, change the mixed numbers to improper fractions, 3 1/8 to 25/8, and the 4 to 4/1. Then multiply all the numerators, next multiply all the denominators, and finally reduce to its lowest terms, 6 1/4. Pause the video here and do the multiplying fractions practice problems on page 21. When complete, continue the video to see the answers. Repause the video and check your answers. Dividing fractions. Change the mixed numbers to improper fractions. Next, invert, meaning turn upside down, the divisor and multiply. And as always, reduce the fraction to its lowest terms. In this example, first change the mixed numbers to improper fractions, 5 1/4 to 21/4, and 1 1/2 to 3/2. Next, invert the divisor and multiply. Finally, reduce to its lowest terms. Pause the video here and do the dividing fractions practice problems on page 22. When complete, continue the video to see the answers. Repause the video and check your answers. When working with decimals, the numbers to the left of the decimal point is the whole number. The numbers to the right are the denominator in decimal fraction, like tenths, hundredths, and thousands, and so on. Decimals are added and subtracted in the same manner as whole numbers. However, with decimals, the decimal points must be aligned vertically. Decimals are multiplied in the same manner as whole numbers. The decimal points are disregarded until the multiplication is complete. To find the position of the decimal point in the final answer, count the total number of decimal places to the right of the decimal point in the numbers being multiplied. Then set off these numbers of decimal places in the answer starting at the right. Pause the video here and do the adding and subtracting practice problems on page 23. When complete, continue the video to see the answers. Repause the video and check your answers. Pause the video here and do the multiplying decimals practice problems on page 23. When complete, continue the video to see the answers. Repause the video and check your answers. Dividing decimals is identical to dividing whole numbers, except that the decimal point must be properly placed in the quotient. To place the decimal point in the quotient, count the number of places to the right of the decimal point in the divisor. Add this number of places to the right of the decimal point in the dividend and place the decimal point directly above in the quotient. Pause the video here and do the dividing decimals practice problems on page 24. When complete, continue the video to see the answers. Repause the video and check your answers. Working drawings in construction projects are typically dimensioned in feet, inches, and fractions of an inch. It is often necessary to add and subtract measurements in feet and inches to calculate overall distances and determine missing dimensions in a dimension string. Adding dimensions are done in the same way as adding whole numbers and fractions previously covered. Add the inch values and feet values separately, beginning with the inch values first. In this example, 12 foot 3.5 inches plus 9 foot 6 inches adds up to 21 foot 9.5 inches. In the second example, 12 foot 3 inches plus 9 foot 10 inches, the answer is 21 foot 13 inches. Now subtract 12 inches from the 13 inches and add it to the 21 feet and you get 22 feet 1 inch. Subtracting dimensions are done in the same way as subtracting whole numbers and fractions previously covered. If the number that is being subtracted from the dimension is less than the value being subtracted, you will have to borrow 12 inches from the whole foot value number and add it to the inch value. Then perform the subtraction. In this example, the answer is 2 foot 9 inches. Finding missing dimensions is a very common task when working with construction drawings. First, find the overall dimension of the string that contains the missing dimension. Then add all the dimensions in the string that contains the missing dimension. As seen here, 5 foot 6 inches plus 3 foot 1 inch equals 8 foot 7 inches. Then subtract the sum from the overall string to find the missing dimension. In this example, you would subtract 8 foot 7 inches from 24 foot 3 value. Remember, you can't subtract 7 inches from 3 inches. You have to borrow 12 inches from the 24 foot, then perform the subtraction. The missing dimension in this example is 15 foot 8 inches. It can become more challenging very quickly as you will have the opportunity to experience in the Test Your Knowledge activities at the end of this unit. When working with fractions, it may be easier to convert the dimensions to decimals. First, convert the fractional inch value to decimal inches. Then add the value in decimal inches to the value in whole inches. Next, divide the value in inches by 12 to convert to decimal feet. Finish by adding the value in decimal feet to the value in whole feet. Example: convert 12 foot 3 3/4 inches to decimal feet. First, convert the fractional inch value to decimal inches. 3/4 of an inch equals 0.75 inches. Then add the value in decimal inches to the value in whole inches. 3 inches plus 0.75 equals 3.75 inches. Next, divide the value in inches by 12 to convert to decimal feet. 3.75 divided by 12 equals 0.3125 feet. Finish by adding the value in decimal feet to the value in whole feet. The final answer ends up being 0.3125 feet plus 12 feet equals 12.3125 feet. In your textbook is a table converting all common feet, inches, and fractions to decimals. In this column, we are dividing the common fractions by themselves to convert to the decimal inch values. Please note, these are decimal inches, not decimal feet. 1 divided by 16 equals 0.0625. 1 divided by 4 equals 0.25. 3 divided by 4 equals 0.75 inches. To convert decimal inches to decimal feet, divide by 12, as shown in this column of the table. Note, you cannot add decimal feet and decimal inches together without first converting to decimal feet. Converting inches to decimal feet is done by dividing inch value by 12. For example, 1 divided by 12 is 0.0833 feet. 4 divided by 12 is 0.3333 feet, and 8 divided by 12 is 0.6667 feet. This table shows all the inch values converted to decimal feet. And finally, the entire table from the textbook. Basic shapes, finding the area. A square and a rectangle should be self-explanatory. A circle is pi times the radius squared. Additional characteristics of a circle are shown here. The circumference is the distance around the circle. The diameter is the length of the line running between 2 points of the circle passing through the center. The radius is 1/2 the length of the diameter. A sector is the area of the circle along an arc. A chord is a line inside the circle, and a segment is the area inside the chord. And a tangent is a line meeting the circumference at a single point. So back to how to compute the area of a circle. The formula for the area of a circle is pi r squared. First, let's discuss what the value of pi means. It is the relationship of the diameter to the circumference of the circle, expressed 3.1416, rounded to the first 4 decimal places. Pi is an infinite number, so we use 3.1416. So if the diameter of a circle is 1 foot, the circumference of the circle would be 3.1416 feet. So we use pi to calculate the area of a circle. Finding the area of a circle example. The radius is 6 feet. The calculation for the area is pi 3.1416 times 6 squared, which is 36. 36 times pi is 113.0976 square feet. Finding the area of a portion of a circle or segment is done by calculating the portion of the arc in percentage to the full circumference. In this example, 195 degrees divided by 360 degrees equals 0.5417. Now multiply this value by 113.0976, and the area of this portion of a circle would be 61.2650 square feet. Finding volume. Volume is found by multiplying the area by depth or height. When calculating volume, make sure to keep all the measurements in the same units. If needed, convert inches to decimal feet. A few words about construction calculators. There are several handheld devices. My favorite is made by Calculated Industries, which also has an app version available for smartphones and tablets. Test your knowledge. Pause the video here and review the material in Unit 2. Then answer the questions on page 29. When complete, continue the video to see the answers. Repause the video to review the answers. Activity 2-1. Pause the video here and answer the questions on pages 30 to 36. When complete, continue the video to see the answers. Repause the video as needed to review the answers. This completes Unit 2. Please visit my website, www.printreading.us, for additional videos.